At first glance, America's largest warship appears invincible, a floating city more than 1,100 feet long and weighing over 100,000 tons. But on a fleet where just 11 carriers must project force across the globe, size alone is not the real secret arsenal. The Ford class is designed for a different kind of firepower, a relentless pace of 160, even 270 strike sorties a day. How do you turn raw scale into sustained combat power? The answer is rarely what you would expect, and it rewrites what Deadliest really means. Steel towers above the waterline stretching 1,106 feet from bow to stern. The USS Gerald R Ford displaces nearly 100,000 long tons, more than the weight of 250 fully loaded Boeing 747 aircraft. Commissioned on July 22, 2017, this ship is the flagship of a new class, built not just for size but for purpose. The flight deck alone covers nearly 5 acres, wide enough to host a city block. Below, a labyrinth of decks, machinery spaces, and living quarters supports a crew of over 4,500 sailors and air wing personnel. Nuclear reactors deep within the hull generate enough power to light a small city. Every inch of the Ford is engineered for endurance, from the armored hull to the labyrinthine passageways connecting command engineering and the hangar bay. This is more than a ship. It is a floating city designed to carry war across oceans, its immense scale the foundation for everything that follows. Across the world's oceans, only 11 American aircraft carriers stand watch. Each represents a rare asset, 1/11th of the US Navy's total carrier force. This number is set by law, and it never stretches far enough to meet every demand. At any moment, several carriers are in maintenance, others are training, and just a handful are forward deployed, covering vast regions from the Pacific to the Mediterranean. The scarcity of these ships shapes every operational decision. When a carrier leaves port, it becomes a centerpiece of US military power abroad, with its presence, or absence, felt by allies and rivals alike. Every deployment is weighed against global commitments and the need to keep the fleet ready for the next crisis. With so few carriers, each one must deliver maximum impact, sustaining operations for months at a time. The entire fleet acts as a single strategic instrument, its limited number raising the stakes for every mission and every day at sea. Combat power on a carrier is measured by the number of sorties it can generate, not just in a single burst, but day after day. The USS Gerald R Ford was designed around this metric. Department of Defense testing set the bar at 160 sorties in a standard 12-hour fly day, and up to 270 sorties during a full 24-hour surge. These are not just targets on a chart. Each number represents a cycle of launching, recovering, refueling, rearming, and relaunching dozens of aircraft in tight succession. Compared to the previous generation, Ford's design aims for a 33% increase in sustained daily operations and a 12.5% edge during surge. Every major system on board, from the elevators below deck to the launch systems above, exists to feed this relentless tempo. The ship itself becomes a production engine, measured not by its size, but by how many times it can put strike aircraft into the air when it matters most. Deep inside the USS Gerald R Ford, a network of 11 advanced weapons elevators forms the backbone of the ship's hidden arsenal. Each elevator is built to lift up to 24,000 pounds, more than twice the capacity of those on Nimitz-class carriers, and moves at a brisk 150 feet per minute. That speed and strength transform the rhythm of combat operations. Ordnance travels vertically from secure magazines to the flight deck with a precision that cuts out the long, winding routes of the past. The final elevator was turned over to the crew on December 22nd, 2021, completing the system after years of engineering and troubleshooting. These elevators are not just mechanical lifts, they are the arteries of the carrier's combat output. Every bomb, missile, and pallet of ammunition moves along these vertical paths, timed to meet the relentless demand for rearming aircraft between launches. The design eliminates traditional bottlenecks, letting ordnance handlers keep pace with the high sortie rates demanded by modern naval warfare. In practice, this means less waiting, fewer delays, and a flight deck that never runs dry when the tempo climbs. The entire system is driven by electromagnetic propulsion, using linear synchronous motors for smooth, reliable movement. Automation trims down the number of sailors needed to operate the elevators, while advanced safety interlocks protect both crew and cargo. The result is a workhorse system, quiet, fast, and nearly invisible to anyone not tracking the flow of weapons beneath the deck. By compressing the time it takes to arm and rearm the air wing, these elevators set the tempo for sustained high-intensity operations at sea. Steam catapults once defined carrier launches on the USS Gerald R. Those catapults have been replaced by electromagnetic power. The Electromagnetic Aircraft Launch System, known as EMALS, uses linear motors to hurl aircraft from the deck with precise adjustable force. Instead of building up pressure with boiling water, EMALS draws electricity directly from the ship's nuclear reactors. Those reactors deliver triple the electrical output of the previous Nimitz class. This surplus does not just power launches, it powers radar, weapons elevators, and the entire suite of advanced systems across the ship. EMALS brings more than raw strength. Its real advantage is control. Operators can tailor each launch to the exact weight and configuration of any aircraft. From heavy strike fighters to future unmanned drones, this flexibility reduces wear on airframes and opens the door for new types of missions. Launch cycles are faster too, with less downtime between shots and less waiting on the deck. The old clouds of steam and hours of catapult maintenance have given way to quiet, repeatable launches hour after hour. Every launch is a link in the carrier's combat chain. The reactors feed EMALS. EMALS drives aircraft into the sky, and the entire system is built to maintain the relentless pace demanded by modern warfare. On the Ford, electricity is more than a utility. It is the force that keeps sorties flowing, making the launch system itself a critical weapon in the ship's arsenal. On the Ford's flight deck, the FA-18EF Super Hornet stands at the center of the carrier's offensive punch. This workhorse fighter launches with a mix of precision-guided bombs and air-to-air missiles, ready to defend the fleet or strike targets ashore. Its arsenal includes the AIM-120 AMRAAM, a radar-guided missile that first entered Navy service in 1993 and has evolved through multiple upgrades, with the C-7 variant reaching operational status in 2008. For close-range combat, the AIM-9X Sidewinder brings high agility and modern sensors, building on a legacy that stretches back decades. Every sortie flown by the Super Hornet means another opportunity to put these weapons on target, turning the ship's raw sortie numbers into real, repeatable firepower. Stealth and information dominance begin with the F-35C, a carrier-based fighter that costs over $102 million per jet. Beyond its radar-evading shape, the F-35C fuses radar, infrared, and electronic data into a single cockpit display, letting pilots detect and track threats before they are seen. In August 2016, the Navy completed final at-sea tests to prove the F-35C could operate seamlessly from a carrier deck. Overhead, the E-2D Advanced Hawkeye manages the air battle, sharing a real-time view of the battle space with every ship and aircraft in the group. Meanwhile, the EA-18G Growler sweeps the skies with electronic jamming, blinding enemy radars, and communications. Together, these platforms turn information into survival, finding threats, disrupting defenses, and guiding every strike with precision. Every layer of defense on the Ford is wired into a network that stretches across the entire strike group. The evolved Sea Sparrow missile, ESSM, stands ready for high-speed threats at medium range. Closer in, rolling airframe missiles and the Phalanx CIWS, firing up to 4,500 rounds per minute, form the last barrier against incoming missiles and aircraft, but the real edge comes from Cooperative Engagement Capability, CEC. This system fuses radar and sensor data from every ship and aircraft nearby, letting one platform guide another's weapons. In July 2024, Navy fighters began deploying the AIM-174B, an air-launched missile with range and punch once reserved for ships, all cued by the shared network. The result is a defensive shield that acts as a single coordinated brain, extending the carrier's reach and keeping threats at bay. Right now, just 11 carriers define America's global reach, each a rare moving arsenal. As rivals race to counter this edge, the real weapon is sustained, networked power at sea. The future of deterrence depends on keeping that advantage real. What does that mean for the world's next crisis?